Okay, it's good to have the opportunity to speak here. Since this is the first time that MarkLogic has attended an LDBC meeting, just wanted to give you a quick overview of who we are, what we do, because most of us are geeks here. I'll keep the marketing quick and delve a little bit into the internals of what we do as well, and then hopefully end up with some use cases that we're seeing our customers doing and some possibilities for ways to produce benchmarks or extend benchmarks in the future. So first of all, what is MarkLogic? What do we do? We've been around for about 12 years now, and even though we call ourselves a NoSQL database, we predate a lot of the other NoSQL databases. As you can see from the slide, I mean, I won't really go through all of this stuff, but we're quite a feature-rich database. We've got lots of stuff going on. And as well, we've got a nice logo slide too, with some high-profile customers. So when MarkLogic was started, well, the main idea actually our founder had was he actually came from a full-text search background. And the main idea was to combine full-text search and database and make the two one product, basically. So full-text search is one of the kind of core things that we do. It's one of the ways that we're architected. Our index structures are all architected around full-text indexing techniques, and because at the time, anyway, if you were doing any kind of full-text work with human language content, there was only one standard really that people were using at that time. So we've become known as an XML database because that was what people needed to use at that time. But actually, what we've done since the early days has gone a lot beyond that. So one of the things that we noticed, maybe going back a few years now, is that we started to see that people were building search applications using content stored in MarkLogic, but then they also started to use a triple store alongside it to do to actually understand the context in which the data existed, and actually relate that to the real world and to the intent behind the person who was searching's question. And so having seen this trend increase, we decided that actually we could do a decent job of pulling that inside the database and having the two systems work together inside MarkLogic. So what we've ended up now with is, although we are born a document database and are quite happy storing XML and JSON documents and things like that, what we've added over time is a triple store inside the database as well, and it also says data store here. We have SQL interfaces and things like that. So now, delving a little bit more inside what's actually happened in the course of developing the triple store, the Sparkle implementation. MarkLogic was a very good, kind of robustly built scale-out architecture for storing data, which happened to have an XML front end on it. But the kind of foundational layer where you can scale out, you can replicate, you can do incremental backups and all of that stuff, the transactional engine was robust enough that through each of the other layers it was possible to build another stack, another front end on top of that to be able to store RDF and execute Sparkle. So at the index layer, where we've already got full text indexes and range indexes and geospatial, and actually that exclamation mark is meant to represent alerting, which is another interesting feature. It's like a reverse index. You use a document as the query, and the queries are what you expect to get back. So you can think about that maybe as a dating website. I'm looking for someone who matches these criteria, and that goes into the database, that query, and then you can turn that around and find out who's searching for someone that looks like this. But alongside those indexes, we added a triple index, which actually looks a lot like the kind of primary storage that's in a lot of triple stores that are out there right now. And a cache, obviously, that works on top of that to keep things in keep things in main memory. We've already got a lot of different languages now on the front end. A little bit of revisionist history here. It says xQuery we've had from the start, SQL we've had for a number of years. Actually, JavaScript we only added recently, so it wasn't there when the semantics was actually built. But then obviously we implemented Sparkle. Some really nice kind of synergy with the xQuery implementation, because a lot of the operators from Sparkle come from xQuery, and the data types obviously come from XML schema, so we already had good support for all of those in MarkLogic when we built this. And then on the front end, where we've got REST APIs, we actually extended our bulk loader to load RDF, and we implemented the Graph Store API and the Sparkle REST endpoint and things like that. So one of the kind of secrets underneath the covers is that actually triples live in documents in MarkLogic. Now, if you just present us with a bunch of triples, you don't ever need to know that we're putting them in documents. You can forget about that detail. But actually it has some nice consequences later on in the way that you can use this. Just a kind of a bit of a justification, I suppose. Why do I think documents are relevant here actually at all? Well, quite often we understand that triples will have metadata. We've already talked about reification this over the last 2 days. And people sometimes talk about, well, you know, is 3 values enough? Should we have 4? Should we have 5? Should we have more? And I guess the question I'm posing is, you know, why would you just extend it by a few places of more information? We need arbitrary contextual information, really, and documents can provide that. If you flip that around, we know full well that a lot of RDF exists in document form. Even if that is, you know, the FOF file, it's still a self-contained unit, a document that contains an amount of information in RDF. But then when you start thinking about RDFA and schema.org and metadata like that, you start to understand that there's actually real content, and then there's semantics about that content embedded in it. And so quite often that's really useful. And as I was saying before, what we've seen is that a lot of people who've been using us as a place to put their content have needed to add support for RDF and support for contextual information alongside that. And that really increases what you can do with your content once you start to be able to understand it more, you know, with the knowledge base that you've built up. So one of the interesting aspects of the MarkLogic implementation, which I think is reasonably unique, is that although we've got our index of triples, that's actually extended to include the information about which documents those triples came from and which positions in those documents they were at. And positions are not on by default, but it's part of the full text kind of infrastructure that we have. When you have full text and you store where a word is, you store where it is in the document, so you can do phrasing and things like that. And it means that with this information alongside the storage of the triples, we can use any of our other indexes. They're all interoperable. And actually, there's a couple of different ways that you can do that, kind of forwards and backwards. You can find the documents that contain facts, but you can also restrict the facts that you're looking for depending on the characteristics of the documents that contain them. And that's actually the basis for quite a lot of the functionality that we provide by default. I mean, you can use that with the full text index, obviously then looking for triples that contain certain full text kind of matches. You can use it with the range indexes, and one of the interesting things there actually is is the way that we do our bitemporal support, which has recently been released. And bitemporal is backed up by 4 different range indexes on the start and end system time, the start and end valid time. And simply by having those dates in the document alongside the triples, you can then narrow the triples that you want to query to a specific bitemporal operator. I mean, the simplest of which would be, what did I know back in 1979 or something like that. And then you'll find that you've got a database, at least a view of the database, which is constrained only to the triples that existed at that date and time. Another kind of obvious use of this is security. Security in MarkLogic is implemented as a transparent query. You don't get to add the query, but it gets added automatically. The query is basically, what documents can I see, can my user see, and so the triples are automatically constrained to only those that you're allowed to see by the system. So I like to talk about this sometimes in terms of arbitrary subsets of triples. In fact, you can slice and dice the triples that are in MarkLogic in any way you want to. So here's a quick example of setting up an initial document query that says, well, I want the triples that are stored in this directory and that were introduced after this date. And then you run a normal Sparkle query, but you've defined the scope of all the triples that you're querying. And you can do even more than this. Now, I'm aware that these queries can be written in Sparkle. So for instance, this is looking for facts about which countries Nixon visited, but we have a date constraint, and we have a confidence constraint, and we have a provenance constraint in there. And you could write all of that in the Sparkle, but if you do write all of that in the Sparkle starts to look terribly complicated and starts to look far less like the actual question that you want to ask. So this kind of separation of concerns is actually quite powerful. And then another little, a little insight into what we're doing here. We're obviously, query optimization is a major issue with Sparkle and the number of joins that you can have. We've actually got a system that's built on top of simulated annealing algorithm, which has been highly tuned to the particular cost models that we've got. But we use, the normal techniques of column cardinality estimates and sort order analysis and things like that, and introduce mutations to the query plan according to what orders we want from the triple index and what join implementations we should be using and things like that. So on to some of the use cases that we've got. Actually, I wasn't able to include real names in this. I think we've got a few customers who are speaking at our user conference next month. So for instance, Disney and Mitchell One and Broadridge, who are a financial services company. We have but a lot of these fall into kind of the basic semantic search kind of technique. We've seen, I think you're probably familiar with semantic search now, as in basically what SPB is covering and aiming to benchmark. But we've seen a lot of interest in publishing, and coming from an XML content world, the publishing is probably one of our, a major representative of our customer base. But actually also in government, the kinds of people who need to know what you're doing and when you're doing it and why you're doing it in government tend to like to be able to model the world, and also to be able to handle data that comes in all different kinds of formats. The banks have a big use case here. They've got governments telling them they need to keep huge amounts of information about where they got their data from and what data they knew and when they knew it. And again, manufacturing, healthcare, pharma, some of these people are showing a lot of interest in RDF right now. One of the most obvious uses is just to use an ontology or a taxonomy to do search term expansion. So we have a customer who publishes standards, and so the people that use their website come to them and they want to know what standards apply to the manufacturing of the devices that they're doing. And so in this case, they might be making a cardiac catheter, and they want to know what standards apply to cardiac catheters. And there may be some specific to that kind of device, but actually there's other standards which apply which never mention that term. So for instance, standards for implantable devices. And so by having the RDF data describe the domain and say that a cardiac catheter is a type of implanted device, you can automatically expand what you're searching for and find the standards that are relevant to that kind of device. So that's pretty powerful. What we've also seen recently is a customer who's been producing basically it's an app that navigates their content, and that content has got a lot of information in the RDF about it, so about programs, about seasons, about segments from that program, then about the kind of actors that are in those segments, the characters that they play and things like that. So there's a lot of ways in which they can use that in the search, so that if you search for a particular actress, for instance, you'll get back episodes that the actress was in by navigating the RDF to find out that information. But also as well to present a kind of a topic map to the user, so that the navigation is more immersive. They're not just using a search box, they're actually also enabling people to traverse the graph, as it were, and if they watch an interesting segment of program, then they can go and find more segments with that same actress or actresses, or maybe they'll go and find more segments with the same character. In addition to that, they have a recommendation engine, so they're actually recording in the RDF what the user does and then being able to recommend different things to view based on their preferences there. I'm going to skip over that one because I really want to get to the end here and to talk about benchmarking. We see there's a lot of value in semantic publishing benchmark, and we're planning on running that, although it's early stages for us at the moment, having come a little bit later to the game than a lot of you guys. Although the social network benchmark I don't think is terribly interesting to us at the moment. So some ideas for possibly extending or making new benchmarks. I think the recommendation engine is a really interesting use case. You could even do it as an extension to the semantic publishing benchmark. Some of the characteristics will be a greater insert load, because obviously you're having an insert per user request that's coming to the system, and possibly more complex queries when you try and create a page for the user at the other end, because you need to look at the recommendations and figure out what to give them. Facet generation we've already heard about actually here. In terms of someone having a performance problem with it, I think that would make a great benchmark. There's all sorts of aggregates involved in creating the facets, and there's the ability to navigate through the ontology that they've got there. We've seen some data integration. I mean, there's some reference data in SPB, but the use case of bringing together data from lots of different sources would make a decent benchmark, I think, and bridging ontologies and that kind of thing. Also, there's the process of having a bigger update where a new data set comes into the system. A financial regulation which would involve things like temporality, bitemporality, and lots of kind of trades and trade information and things like that, and also data integration from multiple business units.
Okay, so thank you, John. I wonder if there are any questions. Okay.
Thank you, Larry. So I was wondering, by the way, really nice work and a really interesting domain. I was curious whether in the creative industries you see a lot of work on automatic IP infringement discovery, litigation, exchange, all sorts of plagiarism discovery, etc.
Yeah, that's a really interesting question. I can imagine all sorts of ways in which we could apply, but as far as I know, we haven't had anyone who's been interested in that yet.
Okay.
Okay, we can talk forever. We had the chance to talk a lot last night, and I hope we will be able to talk offline later on. But some immediate reaction. So to the benchmark, yeah, we already spoke about these possible extensions, and yeah, these are very good ideas. We have worked in the same domain, and we know how relevant this stuff is. Quick comment on the faster generation. This is already part of the advanced interactive mix. We didn't have the chance to present it yesterday, so that's why you haven't heard of it, but it's already there.
Okay.
A couple of questions about your implementation. So you said you essentially extended the triple index with document ID and position, and this sounds like a great idea if you're storing metadata. But this doesn't sound so relevant if you have information that's coming from a database and not from a document, and it's just sort of redundant. How do you deal with this? That's question one. Question two is tell us something about reasoning support.
Okay, so the first question was about what's the use of extending the triples with the idea of which document they came from. Well, actually, you'll notice I talked about triples and I didn't talk about quads. And one of the first uses of that is that the document, one of the first pieces of contextual information that the documents also contain is the idea of which named graph the triples inside it are in. So actually named graphs are implemented using the documents and using queries to select the right documents from that named graph. As well, our security model is based on it, so obviously we're not going to run anything without having the security model running. Actually, the entire database works on an MVCC basis, which means that we know a lot of documents, but some of them will have already been deleted by the timestamp that you're executing at. And so there's a filtering process that happens even there to say, well, even though this is in the index, I know the documents have been deleted according to what you're looking at, your view of the database, and therefore I need to filter that out. So everything works with reference to the document from the very basic level. So in terms of inference, yeah, I only have 15 minutes and I couldn't go into everything. Given that we can make arbitrary subsets of triples and execute Sparkle across those at any time, materialization wasn't even an option. Being able to manage which triples you could see and couldn't see, make sure that people couldn't see inferences based on data that the security settings said they weren't allowed to see was very important. So we implement a backwards chaining rule-based engine. That's very new, that's just been released in the last month.
Okay, I have one question. Could you tell us a little bit about your roadmap to adopt one of the SPB, I understand, benchmark?
Mm-hmm. Yeah, well, I mean, as I'm sure you're aware, the benchmark landscape for RDF is diverse, and there's some good ones out there. There's a lot of bad ones as well. And it's been a process for us coming at this at a late stage to figure out what's worth running and what isn't. We're definitely coming to the conclusion that the social semantic publishing benchmark is one of the good ones and definitely worth running. So I think that's our highest priority now for benchmarking and performance work in the future. But we've been working on that for a couple of months. So it's still early stages yet.
Thank you very much again.